Hi there. Today we're going to talk about the rate of change. Now, when we talk about the rate of change, we are talking about, at least for a linear situation, we are talking about the slope. The reason why I'm saying the linear situation is because the change of rate doesn't necessarily have to be a constant. You'll see pretty soon that's going to be a constant for a linear line, but the rate of change might be a variable. The rate at which something changes might change as well. But that's another thing. When we think of the rate of change, it's pretty much a slope, so that's why you see rise or run. And what that means is something is going to change while one variable is going to change while another variable changes. And as you see in the line, as we go up, as x changes, y changes as well. And then we have some pretty fun facts right here. Engineers refer to the rate of change of a road as the grade. So pretty much roads sometimes go downwards and they go steep, and when that happens, you sometimes see a sign that says 8%. What that means is as you go down 100 feet, or let's say 100 meters, you go down however many percentage the sign said. So in this case, as we go 100 meters, we go downwards 100 meters. So that's pretty cool. Like I didn't know that. I thought that it meant something else. I was thinking more. I was thinking something else, but I didn't really know that that's what it was. And that's pretty cool. So the rate of change for the road, as far as how much are you changing vertically as you travel horizontally, they express that as a percentage. And by the way, you didn't have to take these notes right here. There's just pretty fun facts right here. Starting from here all the way to here, my students don't really have to take notes. They just enjoy the video. Now you may want to make this graph, and we're going to determine what the rate of change is for this graph right here. In order to do that, you kind of need to find out what the slope of this point is, which shouldn't be much of a problem. As long as you have 2 points and you know how to count upwards and sideways, you can pretty much use a slope equation, because the slope, or the rate of change in this case, is rise or run. Also keep in mind that the axes have names. So the y-axis in this case is earnings, while the x-axis is numbers of hours worked. So I'm pretty sure that the slope is going to be earnings per hours. If these numbers represent dollars on the y-axis, we're talking about dollars per hours, because the rise represents how much we change in y. So the units for that's going to be whatever is on the y-axis, which is going to be dollars, and then run represents how much we change in x, and the units for that, as it says, is number of hours. I feel the graph should have had dollars though, if you ask me, because that's kind of just saying earnings. You could have gotten like 10 goats, 20 goats, 30 goats. This rate of change could have been 5 goats per hour, but I guess we're assuming dollars. So here's the big problem that we're going to talk about. A controller purchases a bulldozer for a fixed amount of money, so that's how much. That's just a fixed number that doesn't change. The bulldozer requires an average expenditure of $5.25 per hour for fuel and maintenance. And the operator is paid $11.50 per hour. So write a linear equation giving the total cost of the operating the bulldozer for T hours. Alrighty. So when we talk about these kind of things and we think of it as a linear situation, like paying something per hour is pretty much linear. We want to think of this equation right here: y equals mx plus b. If you remember what this is called, you should think of it. This is called the slope-intercept form, because we see the slope and the y-intercept. Messing with this equation a little bit, instead of having m for slope, we could have put r for rate, because rate of change is pretty much a rate. Like, how much are you getting paid? That's a rate. I'm getting paid $8 an hour. Things like that. And then our x in this case is t, because time progresses as you're getting paid, or in this case as you investing money into this bulldozer, and this should have been C for cost. Whoa. So this should have been C for cost. So let's look at this. The thing is, when you look at this, you have actually two rates that you use. You have $5.25 per hour that you pay, and $11.50. So really, this is not a single rate that you pay. There are two rates. So it's kind of like saying rate 1 times time plus, and then you're paying another rate, rate 2 times time, where the times are the same, and then some kind of a fixed money that you pay. That's like the y-intercept. So let's put these numbers in there. Cost, and that's going to be changing due to t. It's going to be the first rate, which is $5.25. So 5.25. And the reason why I get to put 5.25 is because cents every 100 cents is $1. Now, if it would have been every 80 cents is $1, that would have been a different problem. But in this case, we're lucky. And then over here it is $11.50 per hour, so that's the second rate. Oh, don't forget the t. Plus 11 cents and 50 times t, plus the fixed amount of the fixed number that you pay. 36,500. There we go. So this is the equation. That was the first part of what I was supposed to do. And I was supposed to call it C, so which I did. Now the second part was assuming that the customers are charged $27 per hour for of bulldozer use. Write an equation for the revenue R derived from T hours of use. So I'm assuming what this really is this person is making an investment. So for him to use it, he pays $5.25 per hour, and then $11.50 per hour, but he earns $27 per hour as we're using it. So I guess we're looking at profit. So write an equation for the revenue. I'm not sure. I think revenue means just the money that you make. So let's make that. So that's the cost. That's how much you're gonna pay. But your revenue, and I like how that's like a single rate, no initial cost or multiple rates. So that's going to be pretty easy. It's going to be $27 per hour. So that's going to be T. So that's R. And then use a profit formula. Oh, there we go. Yeah, I was absolutely right. The profit is revenue minus cost. To write an equation for the profit derived from T hours of use. So pretty much what that is, your profit is always going to be how much money you make minus how much it costs you to make that money. So in this case, it will be 27T, and that's pretty much how much, that's your R right there, minus, and then your cost, which is 5 1/4. 0.25 is just a fourth, times time, and then plus 11.5 times time, and then plus 36,500. Alright, so we got our equation going. So let's see, they should, by now I'm pretty sure they're gonna give us some kind of T for time, so we can actually find some kind of money. Use a result of part C to find the break-even point. Alrighty, so how long do I have to work until I make the money back that I spent in order to get this operation going? So in order to do that, we're assuming that you make no profit, but also this is not a negative number, which means that you didn't lose anything either. So that's 0. And then we have 27. I meant to say, I said 7. I meant to write 7, but I wrote T for some reason. 27T minus 5.5T minus, by the way, this is distributive property. the negative is being distributed to all these numbers right here, minus 11.5, wait a second, that's a fourth. 11.5t minus 36500. Bam. Alrighty. So this right here is going to be 27. Let's factor out the t. And when you combine these two, it's going to be negative 16. And this is the same thing as saying 2 over 4, so 3 over 4. 3/4 t, and then minus that initial number. I'm going to need a new page. Worst of all, I'm going to need to make sure I don't forget these numbers. Let's see if I can do it here. Alrighty, so adding a fourth here would make that 17, which means that 27 take away 17 is 10. But keep in mind, in order to make that 17, I added a 1/4. So it was lacking of 1/4, which means it didn't take a 1/4 away from here. Minus, and there's a t attached. Minus, and then 36,500. Let's move all the way up here. So pretty much we ended up with 0 equals, and then we had 10⁴ t minus 36500, I believe. I believe that was it. I don't want to make a mistake. Alrighty, so we add that number on both sides. 36500 equals, and then 10 times 4 is 40 plus 1 is 41 over 4t. Now I'm going to multiply both sides by the reciprocal. So t equals 4 over 41 times 36500. Let's get a calculator. Accessories. Calculator. Alrighty, so 4 times 365. Whoa, that did not work out. So okay, let's try it again. 4 times 36500. Bam. And then divide that by 41. Alrighty, so I do not like this because we got like a really bad number. Which means, did I make a mistake somewhere along the line? I usually do not make mistakes. That's weird. So this guy needs to work at least that many hours? Wow. 35,000. I mean 3,560.98. Oh, can I? Yeah, let's leave at 0.98. Wow, that many hours. Wait a second. The nice thing is I actually do have the answers. Oh wow. Oh, so this person actually rounded. So I do not like rounding like that, but what are you gonna do? The remaining looks pretty much correct. I think I got all those numbers. Very good. So this individual ended up rounding this to 3,561 hours. What I would have probably done is I would have said 3,560 hours, and then I would have used my calculator, and then like I would have subtracted 3,560. That would have given me a decimal that kind of represents 60. That's supposed to represent how many minutes I have now. So multiply that by 60 because I have 60 minutes an hour. I would have had 58 minutes. Now I have a number of seconds that I can find. So subtract 58 and then multiply that by 60 again. And now we've gotten 32 seconds. But you don't have to do this. This is just me. I like to be more exact. Anyways, I believe that is it. That concludes this video. Yep. So you guys have a fantastic day. I hope I did not bore you with this lesson. But pretty much the main points is slope is the same thing as change of rate. And then we talked about how that plays in real life situations, like if you go down the road, there's a steepness. They call that grade, the construction people. And then also think of houses too, the roofs. They have a certain kind of steepness. I think that has a special term too for people who make roofs. But that's besides the point. And then we did this example. So that is it for today. You guys have a fantastic day.